We'll be talking about branching today, and we'll use a little exercise to explore what that means. So, the solution to the general quadratic equation that we know, which is popularly known as the almighty formula, is what we have here. So, to solve this quadratic equation, we normally use the almighty formula to solve it. And this almighty formula has some parts. Usually the parts under the square root sign is what we call the discriminant. So the solution that you get, so if you are finding a solution to this quadratic equation, the solution you will get is either going to be a real number or a complex number. And the part under the square root usually tells us what type of solution we will get. So if the discriminant, which is the b squared minus the 4ac, if it is greater or equal to 0, we know that the solution is going to be a real number, or the solution is going to be real. If it is otherwise, meaning if the discriminant, the d, is less than 0, then we know that the solution is going to be complex. So we have to write a Python program to find the nature of the solution for these two quadratic equations. So with your knowledge that you know, we can try solving this in two parts. So first, let's find what a, b, and c are going to be. So in this equation here, if you compare it to the general equation, you see that the a is going to be equal to 1, the b will be equal to 2, and the c will be equal to, the b will be equal to 9, and the c will be equal to 8. Yeah, so comparing this to this, the coefficients, a here will correspond to the coefficient here, which is 1, and with the same logic you can fill out the other two. So we can assign the discriminant, which is going to be b squared minus the 4 times a times c. So all that we have to do is to test if the discriminant is greater or equal to 0. So we print that, and then we see that it is true. So what this means is that since d greater than or equal to 0 is true, we know that the solution for this quadratic equation is going to be a real number. So let's try out the same thing for this equation as well, and let's see. Alright, so the next one, the coefficient x, the a will be equal to 1, the b will be equal to, so when you compare this equation to this, you see that the b is not in this equation. For what that means is that the b is going to be 0, because 0 times x will just be 0, so that's why it's not here. So b will be equal to 0, and c will be equal to the 4. So then we can test the solution again using the same things that we already did. So false. So since d being greater or equal to 0 is a false statement, we know that the solution to this quadratic equation is going to be complex. So with our knowledge that we know so far, this is
Please,
how.
you are not sharing the full screen.
I'm not sharing the full screen.
Yeah, like your workings. We can't see your workings. Okay, we can see it now.
Oh, okay. Yeah. Is this clear up to this point? Is everyone clear up to this point?
Yes, please.
Alright. So this is very easy, and with the knowledge that we know, this is how we'll do it. But there's some improvements that we can do. First of all, you see that comparing these two codes, some parts are repeating. So for example, the d equals b squared minus 4ac here is the same thing that we have here, and it's another the same thing that we have here. And because the question is like a branching question, what that means is, if something is something, then something should happen. So what this equation, the line here is testing is if the discriminant is greater or equal to 0, and if it is greater or equal to 0, then we should print real solution. But we've not gotten there yet. But I'm happy with the fact that you understand up to this point. So we can improve upon this using the branching statement that we'll look at. So I'll introduce you to a concept that we call flowchart. So when you have a particular problem, it helps to understand the problem in more detail by drawing flowcharts for those problems. So with this flowchart, the first part of solving this equation is assigning what a, b, and c will be. After assigning what a, b, and c will be, we'll calculate the discriminant, exactly what we did here. So we assigned a, b, and c, and now we are calculating the discriminant. So the first step and the second step. Now we reach the decision junction where we are going to check if the discriminant, the d, is greater or equal to 0. If this discriminant is greater or equal to 0, then we'll print real solution. If it is not greater or equal to 0, that means that it is less than 0, then we'll print a complex solution. So we are reframing the question that we have here, this question here, into a flowchart, and this is what we have. So with this in mind, we will resolve the question using the if, else, or yes or no branching. So this is what we call branching. So the answer to the problem depends on the value of d. So this is the first branch, and this is the second branch. Depending on the value that we get for d, one of these, and the green and the red solutions will be printed. So let's get the first variables again.
Sir, sir, please, I really want to understand this flow um chart well, because most of the solutions that we solve, we use it, which is the
Yeah,
else statement.
yeah.
Yeah, please, I wanted to know the conditions where we use the else statement. If because I was with the exercise we did, I was kind of confused. So I wanted to know situations where we use the else statement
Okay. So
and situations where we use the list comprehension with the else statement.
okay, I will talk about that when I introduce the if and the else statement. Some people are here, they don't know what that is yet. So after I've introduced it, I'll explain. I'll answer the
Yes, please.
question for you. Yeah,
All right. Thank you very much.
yeah. Thank you. So, like I said, we are going to resolve the question again. So we set our variables. So the first part of the flowchart, a equals b equals 0. This is for the second quadratic equation. So here I am setting the first variables. So we are setting the variables for the first quadratic equation. Then the second part of the flowchart is we are going to calculate the discriminant. And we've already done that, so I'm just going to copy this again. So these these lines from 1 all the way to 5 are for the first step and also the second step. Now this part is where we are going to use the if and else statement. So we are going to say that if discriminant is greater or equal to 0, print real solution, else print complex solution. So if the normal English grammar that we know, if the discriminant d is greater or equal to 0, we are going to print a real solution. Then if this statement is not true, meaning that the value we get here is going to be a false statement, then the else statement is what is going to be run. Again, we've assigned our values and we are calculating the discriminant, and then we are saying that if the discriminant, the d, is greater or equal to 0, if this statement here, d being greater or equal to 0, is a true statement, meaning the value here is true, then the print statement will be run. So this is what we run. But if the value here is false, Python will skip this if statement and go to the else statement. So if else statement, if this doesn't happen, else the other part should happen. So that's basically what the if else statement does. It works like the at the decision part of the flowchart. Now, if you type the if else statement, so we start with if followed by the condition and then followed by a colon. So somebody could have done the same thing like this, print real solution, and then you can add the else statement and you can say print complex solution. What I did the first time and these are all the same. So if I did this like this and do it also like this, is the same thing. So I'm going to explain why this is the same. You say that the if statement ends on this line and the else statement continues on the 8th line. Sometimes the part or the script that you want to run or the program that you want to run in the first if statement is not going to fit on one line. So usually we break the if statement into two parts. So after you bring your colon and you hit enter, you see that Python will provide a space before the next line continues. That space tells Python that the coming lines of code are going to be part of the if statement. So that is what that means. Usually if this line is gone and you want to get that space back, you hit the tab key on your keyboard. The tab key for Windows users is the arrow going back and forth. Usually it's on the upper left corner of your keyboard. So when you hit the tab key, you see that the space will be brought, and this tells Python that the line under the if statement is part of the if statement. So you can do the same thing for the else statement as well. If what you are going to do is not going to fit on one line, this is what we do. But for conversion's sake and for best practices, we usually write the lines beneath them. So that is what this means. So if I run this code, see that I get the first print statement to be printed, because the d being greater than or equal to 0 here is a true statement. So because this is true, the print statement for the first if clause is what has been printed out. Let's try the same thing for the other equation. So I'm going to copy all this again, and then all I have to do is to change the parameters for a, b, and c. So for the second equation, a is 1, b is not here, so b is 0, and c is 4. So b will be 0 and c will be 4. If we do that, we will get a complex solution. So what this means is that d being greater than or equal to 0 has resulted in false. So because this is false, Python skips the if statement and goes to the else statement, and we get the complex solution that we get. So this is the branching. Python will decide if the statement, if there is a condition and the condition says it's true, the statement under the condition is what will be run. So here is a pre-statement, so that's what we get. The same thing goes for the else statement too. So because if this doesn't run, then the else statement is what will be run. At this point, please, is everything clear? If it is clear, please give me a thumbs up.
Yes, please.
Okay, so that is the if else statement. Now we are going to, if you understand this, we are going to upgrade the question a bit. So instead of only printing out the nature of the roots, we want to write a program that finds the solution to the equation, and also return the nature of the solutions. So what that means is that we will solve the quadratic equation, give the answer, and also tell us whether the solution is either real or is complex. So to draw a flow chart for this, you know that to calculate this equation, we need a, b, and c. So first of all, we need to assign a, b, and c in the flow chart. Then after that, we can calculate the discriminant. So the discriminant b squared minus 4ac, we can calculate that since we have a, b, and c assigned in the first step. Then the second step, we need to find a solution to the equation. So like I said, everything here under the square root is the discriminant. So to find x, all you have to do is to bring the rest of the variables back. So this is the minus b plus or minus square root of d all over 2a. So the d, which is the discriminant, is what we are putting inside the Almighty formula equation. So from at this point, we can find what the solution is going to be. With the solution calculated, we then print the value. After printing the value, we check if the d is greater or equal to 0. If it is greater or equal to 0, then we print real solution. If it is not, we print complex solution. So this is the flow chart that I drew for this particular equation. So when you are given a task, you have to draw the flow chart on your own. You can do it using pencil and paper, and that really breaks the problem down for you to solve. So with the same equations, I'm going to copy the variables again. In fact, let me just copy all of this. Copy the first one. Okay, so with the flowchart, we need to assign a, b, and c, and that is exactly what we have. After assigning that, we need to calculate the discriminant. Then after calculating the discriminant, we need to find the value of x, or the roots of the equation, and that was going to be equal to negative b. Because we don't have plus or minus on as an operator, we start with the plus one, and then let me space this out. Then we have our d being raised to the power negative 1/2. You can also import the math module and use the square root function on the d. So this is what we are trying to do. So negative b plus the square root of d all over 2a. So this entire expression divided by 2 times a. So this is the first solution of the equation. So I'm going to do this x1, then the next one will be the negative part. minus. So what this means is the roots of the equation are usually 2. So this is why we have the plus and minus sign here. So first the x1 that I signed, we are using the plus, then the x2 will use the minus or the negative. So that is what we have here. I hope everything is okay to this point.
Yes, please. Yeah.
Maybe network. Okay, yeah, sorry about the wait. Okay, so with the flowchart I didn't add the print statement. Okay, sorry, we are going to the print statement. So I'm going to print the x1 and then also print the x2. So now that we are done with that part. So we basically
Sir, please, did you update the notebook?
no.
Wow.
Is
Because
there
I'm not seeing the second condition where we saw for X for the flowchart.
no? It's in there. Probably you missed it. Hello.
Say,
Yeah. Did you hear what I said? I said probably you missed it. So yeah, it's in. I didn't update it at all.
wow. Because it's not in my notebook.
It's not in your notebook.
Yes, please. Say.
Yeah, I didn't update it, so I don't know.
Yeah, it's in there. It's in there.
Oh, okay. So probably maybe you um unintentionally deleted it or something. It could happen.
Wow.
Yeah.
Yes, please. Thank
Okay.
you very much, sir.
Yeah, sure. So we are here now. So we've reached the branching section. So it's the same thing. If the discriminant is greater than 0, we should print this. If not, we should print this. So basically, this is it. So we run this, and then we get two real values. So this is the first one is the print x1. That's the value that we have. The print x2. This is the value, and then of course it's a real solution. So we have this. So we test the same thing on the other equation, which is 1 0 and then 4. We print the same thing, and because the values that we are seeing here are complex numbers, of course the roots are going to be complex. So this is the basically the branching. This is the entire thing. So if you know if else statement, if you are at that junction, you use the if else statement, and only one part of the if else statement will be used depending on whether it is true or false. So I'm going to answer your first question, when do we use the else statement. So whenever you have an if statement, always have an else statement. So if the if statement is false, the else statement has to be available for it to be run. So the else statement is the backup, just like normal English. If something doesn't happen, else something should happen. So the if statement always has to come with an else statement. There are times when the else statement doesn't come, but it's not considered the best practice. So whenever there is an if statement, there is always going to be an else statement. So that is when you use an else statement. When there's an if, there always has to be an else.
Sir, please, I wanted to ask a question.
Yeah.
Please, can we use the else statement for a scenario where we have like a large data set, right? And then we are supposed to solve like we are supposed to find x of the values in that large data set, and then there's a condition that we want to use like a part of that data set, right?
Mm-hmm.
We want to ask Python if that like the slice of that data set is um under a certain condition, and if it's not, it shouldn't print that. So do you understand what I mean?
No. So what I will do is I will um, give you your screen so that you could share, and then you show me the part that you are trying to talk about.
No, no, so I've not coded
You've not
that.
done that. Okay.
No, no, no.
So, but what I can say is that you can use the else statement to do anything as long as the code you're writing is valid. You can use it for anything. It's
Okay.
it's like um, think of it like the if else statements are two cells, just like we have code cells in Colab. So think of it like
Mm,
you have um, two cells like this, these two cells here. So
please.
Python is checking the condition before coming to run this cell. So just like how you can write any Python code inside this cell, it's the same thing as you writing any code um, in the else statement. So you can write anything in this cell if the first statement, which is the if statement, doesn't work, then the second cell has to run. So the else statement can be used for anything at all.
Okay.
I can say that based on how I understand your question at this point.
Mhm. Okay.
So
I maybe along the line
yeah,
that question will really pop
yeah,
up
it will pop
again.
up. Yeah.
Mm,
So if you don't know anything about the pH scale, this is it. Um, you can tell if a substance is acidic or basic based on the pH of that solution of that substance. So usually, if a substance has a pH of between 1 and 4, we say it is acidic. And if it is between 4 and 8, we say it's neutral, like water. And if it is above 8, we say it's basic, like the substance you find in soap, like potassium hydroxide and others. So this is the pH scale that is normally used, and there are colors associated with them using litmus paper. But we are not interested. We are only interested in the pH scale of solutions. And to calculate the pH scale of the solution, you need to know the hydrogen ion concentration in that solution. With that, you can use the log and the negative log of the hydrogen ion concentration in moles to calculate the pH. So that's what this equation here is saying. So with that, with what I just talked about, with that knowledge that you have, if you are given a solution that has a hydrogen ion concentration of 0.0042 moles, use your Python code to calculate the pH of the solution. And the same ranges has been given to you. So if the pH is between 0 and 4, it should return acidic solution. If it is between 4 and 8, it should tell us that it is neutral. Even if it is above 8, it should give us a basic solution. So that is what we have. So in this case, our branching is not going to be 2, it's going to be 3. So if one is correct, that branch, if one branch is true, that branch will run. Okay, so let's get started. So the first thing that we need to do is to assign our variables in memory. And there is no way you can write a function right now, even me to write a function to calculate log. So we are going to stay humble and import the log function from the math module. If you went through the math module, you know that there is a log function in there. So we import the math just so that we will anticipate when we use it, and then we will assign the h plus concentration that we have, which is 0.0042 moles. I don't want to do this. Then we can calculate the pH, which is what we have here. So negative log. To do the negative log, we will import the log from the math module, because that was the reason why we imported this, and then we pass in the h plus value that we have. Yeah. So after calculating the h plus, now we need to do our branching. So if the h plus is between, if the pH is between 0 and 4, then we should print acidic solution. So that's the first one. Now else, if the pH is between 4 pH is between 4 and 8, should print neutral solution. Now then the last thing is the else statement. So else, if the pH is greater than 8, we should print this. So you see that we are having multiple if statements here. So if you have multiple if statements, then after the first, if you go with an else if statement, if you are going to check another condition, because you are going to check another condition, you use the else if statement. But in Python likes abbreviating stuff. So instead of else if, this has been abbreviated to elif in Python. So we are checking that the pH is between 0 and 4. We should print acidic solution. If this condition is false, we move on to the next else if statement. If the pH is in between 4 and 8, it will be exclusive here. We should print acidic solution. If this statement again is false, then we check if the pH is greater than 8. If it is greater than 8, then we print basic solution. Now you can add an else statement, but with the else statement, usually put the else statement after you check all conditions. So just like the first two else statement that we did here, we only check it if d was going to be greater than or equal to 0. The next thing, that the only other thing that d can be, if it is not greater than or equal to 0, is to be less than 0. So we didn't need to check a condition for that. We just have to say else print a complex solution. So here the pH has different ranges. So first we are checking if it is in between 0 and 4, then we check if it is in between 0 and 8, then we check if all these two are not plausible, then we check if it is greater than 8. If the condition doesn't meet any of this, all of this, if it doesn't meet any of this, then probably there's something wrong with the pH value. So you can add an else statement to say invalid pH value. Or if you think that the pH value that you get cannot be anything outside the range that you've given, so 0 and anything between 0 and infinity, then you don't really need to bring the else statement, meaning the if statement has covered all the ranges that you are perceiving. You can do away with the else statement. So if we run this code, one of these three branches will be run. pH is not defined, so it's supposed to be capital H. H. Right. So we get the question to be a neutral solution. Does everybody get this? Any question or anything that thought is bothering you with this, please let me know. If I should go over it again, so I could do that.
Sir, please can you print pH?
Yes, you can print the pH.
Yeah, please print pH for me.
So it's 5.7426.
Hey, wow.
Yeah. So
Sir, I had an acidic solution.
let me see. Share your screen and let me see.
Yes, please.
Yeah. So there is a difference between natural log and then log 10. So the log here is natural log, so you are using log base 10.
So, sir, but log 10 is the same as 1, right?
Log 10 is the same as 1.
Yeah. Oh,
No,
log
log
10 base
10,
10.
yes, log 10 base 10 is 1. But the log that we are using inside this equation is log to the base e. That's what we call natural logs or lean. Some people say lean. So normally natural log is done without putting any base there. Some countries they don't put any base there. So that is what they did here. Yeah.
Thank you very much.
Yeah. Okay. So we are done with that. Now I wanted to send this as an exercise, but there seems to be a lot of um, confusion around this. I wanted what's her name? I've forgotten her name.
Latifa.
Yes,
Latifa.
Latifa to take us through, but she's not here. So um, I will I will let Stephanie show us
Yeah,
hers.
sir. Oh, sir, please, I beg.
Okay, so I'll solve it and I'll explain every part of it. And if there's any question, you let me know. It's not that difficult, so let's see.
Yes, please, sir.
Okay, so the question is we are supposed to find the pH of the following solutions. So these are the solutions. All we know about them is their H plus concentrations. And after we found the pH of these solutions, we are supposed to list the first 5 acidic solutions in increasing order. So what that means is that after finding the pH of these, we are supposed to know which one is acidic and which one is basic. Then after finding the acidic ones, we should list them in increasing acidity. So the first one will be the first acidic solution. The next one will be the one with acidity higher than the first one in that order, and to the fifth one. And then we are supposed to print out. We are supposed to print out the solution with the highest pH and the solution with the lowest pH. Then we generate a zip of the pH and also the concentration. So the first column will be the pH and the second column the first column will be the concentration and then the second column will be the pH. So let's start with generating this list. So when you look through the list, is not in uh, it's not in any order. So we have to hard code it. I can't do that, so I'm just going to copy and paste. Alright, so then we calculate the pH of these solutions. So the only way that you can do this is to use list comprehensions. So pH we've already imported the math module, so you don't really need to import it again. Say I for I in concentrate. This is just too long. We just use this. Yeah. So we've just calculated the pH using the list comprehensions. Nobody should be confused with this at this point. We've gone through that several times. So then we need to find the acidity of these solutions based on the pH. So the first thing I'll do is I would like to use the else if statement that we already did. So this else if statement already has the ranges already, we've already decided here. So I'm not going to code all of this again. Sorry, but there is a problem. The else if statement only requires a single value. You can't use a list in the else if statement. So what do we do? Another thing that we could do here is to use another list comprehension. So let me just say acidity. So all I will do is since we're only interested in the first 5 solutions, I'm just going to check which of the pHs that I've calculated that is less than the pH range for acidity, so less than 4. So that I'll just put that inside the acidity, let me just call it acidity list so that it will make sense. So we are just returning all the acids. X for X in pH if pH is less than now. I know you guys know this, so this is the normal list comprehension that you know, and if I take out this if statement from here, I know that you people also understand what this is. Now with the if statement, with the list comprehension, you can also add an if statement. So what the if statements will do is like what we already talked about. For each of the values in the pH, it will check if those values is less than 4. If they are less than 4, then those are the values that will be returned. So this is one of the situations where you can do an if statement without adding an else statement. So with the normal if statement, we are saying that for X in pH, print the X. We are adding a condition that if the X is less than 0, then you should print the X only when the X is less than 4, not 0, than 4. So I'll print the pH and the acid so that you see the difference. If they are all less than 4, all will be printed. If not, only the ones that are less than 4 will be printed.
So say, please, I want to ask, you can use else if here, like I
Yeah,
say, if x in pH, if x is less than 4, else if x is greater than.
I have not really done that before, but let's see. Let's see. I've not really gone to that type of step before, but let's see. Mm, X is, let's say, it's in between something. So let's say it's in between uh, probably 10,
Okay.
something like this. Let's see.
Mm.
Let me print the acid and see. Yeah, it won't work. So it only takes the if statement. That's why I'm saying that this is the only part where if you don't add an else statement, Python will not fight with you. So it can take the for loop, it can take the if statement, but anything other else it won't allow.
Okay.
Yeah.
So this is just to state the condition
Yes, you're just
of the value
adding.
statement.
Yes, one. You can only add one condition when you're using the list
Yes. Yes,
comprehension.
please.
Yeah.
Yes, please.
So I was going to leave this to you guys to figure out on your own, but because you guys um, were not understanding, I had to bring it here. Okay, so the first one we have the P, the second one is empty. Why is that? Oh, are we supposed to be four? Okay, so yeah, so it it means um, we don't really have any acidic solution here. We have basic and neutral solutions here. So you guys actually lied to me. So I'm going to check for the solutions that are basic as well. So for basic solutions, it has to be in between greater than or equal to 4 or less than, what was it? Less than 8. I'll check for neutral too.
So I think because of the log 10 I used,
Ah,
that's
okay,
why
okay,
I
okay, okay. Yeah,
said
you guys use log 10. Yeah.
yes, please.
Okay, so I'm going to introduce something here because of how the output is. You don't really know what is corresponding to what. So the print statement, you can add a comment to it. I think I introduced this during the first lecture, but I've not spoken a lot about it. So you can add a comment to the print statement. So let's say this is going to be, let me call this solution pH. So this is the comment I am adding. After I've added a comment, then you separate the comment from the value you want to print by comma. If I run this again, you see that solution pH has been appended as the comment, then the value for pH has is what we have here. So I'm going to do the same for the other one so that I know what corresponds to what. This helps with the output so that we see what corresponds to what. Yeah, let's run this again. So we have our solution pHs, but we don't have any acidic solution here. We have basic solutions and we don't have any neutral
Yes.
solution here. Yeah, were you asking any question? So it means that all our solutions are basic and we can use we can still arrange them in increasing acidity, because on the pH scale the acidity increases from here all the way to the end. So whether it is basic or not, we can still list them from the least acidic um, to the from the least basic to the most basic, or in reverse from the most acidic to the least acidic. So this question is rather complex than I thought. But please, before I continue with the next part, does everybody understand what I just did here? Do you guys understand this? Or I should go over it again? Hello? Okay. I don't know what happened, but let's see. So with this, we can now arrange our basic solutions from the most acidic to the least acidic. So if you if if you looked at the global solutions, the global functions that we talked about, if you went and looked at the list, you know that there is a function called sorted. What the sorted does is to sort a particular list from the least to the highest. So we want to sort the basic solutions from the least to the highest. So we pass the neutral in there and then we'll see what we'll get. Oh, sorry, not neutral, basic. Basic solutions. So this is the basic solution from the least basic um, to the most basic, but because we say this relates the from the least acidic to the highest acidity, this has to be reversed, because since these are basic solutions that are here will have the most acidity, and the solutions that are here will have the least acidity. So if we are um, arranging the basic solutions from least basicity here to highest basicity here, for acidity it has to be reversed. And if you look at the sorted function, there's a parameter that you can give um, to reverse the listing. So that's what we call the reverse argument. All of these, if you look at the global functions list, you will find all this information there. So this is what we have, but there is another layer to this question, because we are supposed to find the first 5 solutions. So with the first 5 solutions, we are just going to use uh, slicing. I'm just going to store this inside a variable. I'm going to call this source, and then I can slice to get the first 5 um, solutions. So 1, 2, 3, 4, 5. So we've passed our time, and that was just the first part of the question. I didn't really solve it, so when you guys send it, I just looked through and to see if there are any changes. But this is it. So
Yes.
think the problem is from the acidic solution and then the log that we
The log
used.
that you used, yeah.
Most they're using basic solution.
Yeah. Okay, so I will leave the other parts for you guys to do and to try your hands over all this again. And I will see you guys next week on Tuesday. We spent all our time, so thank you guys for
Mm,
joining. I don't know what
yes,
happened
please.
to um, Latifa, but I hope she comes back.
So I mean, I'm even experiencing lighthouses. I can't even share my screen to share my the second solution and the third solution with.
Okay. We'll do that on the next meeting. We'll allow you to share it so that we will see.
Yes, please.
All right. So thank you guys for joining. We'll see you guys on next week Tuesday.